So another way to look at subnetting is called classless interdomain routing, or CIDR for short. And essentially what CIDR is a shorthand representation of a subnet mask. Because a subnet mask, as you saw before, just tells us how many bits belong to the network portion and how many bits are left remaining for the host portion of an IP address. So what a CIDR does is simply comes in and uses this slash notation, and all that value after the means after the slash, the number after the slash relates to how many bits belong to the network. So in a class A address for a private address range, anything that's a /8 is a class A sized address. Anything with a /16 is a class B. Anything with a /24 is a class C. So we can characterize the size of a network by the subnet mask or the CIDR. They both provide the same result. It's just a different way to assess or look at that subnet mask value. So one thing to think about, if we change, say, that class B CIDR from /16 to 17, what we've done is doubled the amount of networks that are available to us. Because remember, we're dealing with binary. We do everything in multiples of 2. So if we take 1 bit away from the host portion, we've divided the number of hosts in 2. So if we take away, we divide. If we add, we multiply in binary. So we turn that 16 to a 17. We've taken 1 more bit from the hosts, divide the hosts in half, but we've created 2 networks. So a good way to think about that is if you look at a /24, a class C address range, that accounts for 254 usable IPs, or 256 total IPs if you include the network ID and broadcast IP. So if I change that network to a /25, it would make 2 networks that are 128 IPs each. Remember, because we double the networks and we divide the available IPs in 2. So we had 256 total and 1 network, but we took a host bit away, so we had to turn it into 2 networks with half the number of hosts. If you own both of those networks, you in theory have the same amount of IP addresses, but they're now split into 2 distinct networks. So to make use of CIDR and subnetting in this respect is what's called variable length subnet masking. So imagine you're a network admin and you want to build out a few networks to support some business functions, but due to the IP addressing that's been leased within the private network, you don't have a lot to play with. So you're given this chunk of IP address ranges to work with, but you have to optimize it. You need 5 small networks from 1 big network. So you can use variable length subnet masking, which is essentially using subnets to overlap one another. So as we just saw previously, taking a host bit away doubles the number of networks, but divides the available hosts in half. So by doing this in conjunction with other subnets and planning it out, it's a manual process that an admin would have to go into these devices and configure. You can turn a whole bigger piece into smaller pieces. So we can equate that again to a pizza that's not cut yet. You're given a pizza and you need to share it with 8 people, so you have to cut it in 8 slices. But what if somebody only eats pizza if it's the size of 2 slices? So, okay, well, that person needs a third of a pizza, and everybody else is going to get, 7 thinner slices. So we've got 1 big network, 7 smaller networks. And that's essentially what VLSM is. Another way to look at it is if you wanted to count $100, we can hold a $100 bill in our hand, and we all understand that concept of what $100 means. But you can also make $100 out of 1s, 5s, 10s, 20s, or 50s, or a combination thereof. So think about it like this. You are an admin who has a $100 network, but you need a $50 network, 2 $20 networks, and a $10 network. So you can use VLSM, or variable length subnet masking, to use these different denominations of sizes that still equate to the whole $100, but it's broken up into more manageable defined values that you can now divvy up. You can give somebody a $10 size network, you can give out the 2 $20 size networks, and then you can give somebody who needs that big $50 size network, so that everybody has just enough IPs for their use case, but we're not wasting IPs because we had to give a really big network. We don't want to give $50 in IPs when somebody only needed $10 in IPs, right? We have $10 networks for that use case. So what does all that mean for us? It means don't work harder, work smarter. Like I said, it's important to understand subnets and CIDRs and VLSM, and I would say it's important for you to take some time to go study some more on that and go learn more about that. But at the end of the day, when we think about network defense, analysis, reading logs, and triaging events, it's more about, is this a public or private IP? And generally, how big is that network? And you can do a lot of that by looking up subnet calculators online. You can use your calculator on your desktop. If you click that hamburger icon, the 3 lines, you can select programmer mode for standard for scientific. And we can see in programmer mode here, I put in the base 10 value of 127, and it then gave me the binary value right there. So at the end of the day, understand how this stuff works and why it works that way, but you're not an IT admin. You're not configuring routers as a defense cyber person unless you want to do that stuff. If you're interested in getting into IT, switching and routing, you're going to really need to know this stuff. You're going to need to know how to do subnetting by memory, by site. But for the most of us, a calculator, an online calculator, is more than sufficient to be able to calculate this and understand the sizing of networks and helping us scope our work.